All right. So this packet of notes has simplifying radicals, multiplying them, and dividing and rationalizing. It's got all of it in there. Today, it's Friday. We're going to kind of ease into this. We are just going to simplify today. Okay? Very basic. Because my hope is to not overwhelm you for the weekend, right? So we're gonna go over just a very short part today. I think most of you know how to do anyway, so we'll just kind of refresh your minds on it. We have an activity over the whole exponent stuff. We'll work on that, and then you'll have a homework assignment for tonight, but hopefully you have plenty of time to work on all of it, okay? There we go. All right, so looking at simplifying square roots or simplifying radicals, if b squared equals a, then b is the blank of a. It is the square root. Yeah. So if 3 squared equals 9, then the square root of 9 is 3, right? You guys know what square roots are, I hope. The symbol used to denote a square root is a radical sign. What's the symbol look like? Was that sound effects even back there? Boop, boop, boop. All right, so your radical sign's like a little check mark with a line. All right, that's a radical. Does the length of the radical make a difference? It really does. And as our equations get bigger and more intense as the chapters go on in here, I will like be very picky on that. We're talking about just regular numbers today, so it shouldn't be a problem. And then an expression containing a square root is simplified when all perfect square factors have been removed. Now, there are different ways different teachers teach this. I've taught it different ways throughout all the years. This is my 16th year of teaching, so I've done it many different ways. So I'm going to teach you guys, if you've not already learned it, the way I think most students understand it the best, and they're the fastest at it. Okay? Are you allowed to just type it in your calculator and tell me what the decimal is? You will learn very quickly with me, I hate decimals. If it can be a fraction, write it as a fraction. If it can stay in a radical, you leave it in a radical. Okay? I do not want decimals. Why would I not want decimals? A lot of times, yeah, they go on and on. So are they very exact? If you're building a house and you rounded off every calculation you did, will you notice it? Uh-huh. Some of you had that look on your face. Yeah. If you round something and then continue using that rounded answer through everything, it's going to change your answer dramatically. Depending on what lab you're in, you probably really know that. Okay, so I like exact answers. All right, so the way that I like to teach this that most students understand the best is we make factor trees. Taking you back to grade school, right? Factor trees. You mean you love this? Yay! All right, so if I look at square root of 24, is there a perfect square root of 24? Is there a number times itself that makes 24? And there's not. It's not a perfect square. So instead of just typing it in my calculator and getting a decimal, I want you to simplify the radical. So we do a factor tree. So I know like I could have went 3 and 8. I could have went 4 and 6. There's different ways to make 24. It does not matter which way you start. It does not matter. Okay, so for me, I went 2 and 12. 2 is a prime number. What does that mean? Can I break down 2 any further other than 1 times 2? Okay, so that means it's prime. I can't break down any further. So my suggestion to you is any prime numbers you hit that can't keep breaking down, circle them, because those are the ones we want to look at. Okay, 12 I can keep breaking down. That's 2 and 6. Again, 2 is prime. I'm going to circle it. And then 6 breaks down to 2 and 3. Bless you. So those are all my primes. Now this is along the side. It's kind of a textbook how they set it up. I don't make you write all of that. Okay, so what I do once you get to your factor tree method, you were looking for pairs, because a square root is a number times itself, right? 2. So if I'm looking for pairs, what do you have a pair of? I have a pair of 2s, right? So there's a 2 and another 2. That pair comes outside. I always think of it as you're going on a date, right? You have a date with somebody. The 2 of you make one couple when you go out together. You're one couple, right? You're not individuals anymore. You're one couple. Now, if you don't have a date and you're single, you have to stay inside, right? A single 2 and a single 3, they're going to stay inside, and they multiply together to give me 6. So pairs or couples on a date come out. And then if you are single, you have to stay home inside. Or the other way people have thought about it as they're leftovers, right? I pulled all my pears out and then I have leftovers. Where should you put leftovers? Oh, in the trash. I love leftovers. You put them in the fridge, right? You put them in. They're inside, not the trash. Leftovers are the best. I don't have to cook a full meal. I just stick it in the microwave and I'm done. Right? Leftovers go in the refrigerator. Put those inside. Have you guys, how many of you have simplified radicals by this method before? Okay, about half of you. All right, so number 1, square root of 32. First do me a favor and always double check. Is it perfect? No, okay. What always kills me, if it's perfect and you do a factor tree, you just don't have any leftovers. Everything pairs up, and then they're like, oh my God, what do I put underneath my radical? Nothing. You don't have one, okay? It was perfect, but people always freak out on that. All right, so what do you multiply to get 32? 2 and 16. All right, 2 is prime, so I'm going to circle it. I'm going to keep breaking down the 16. 4 and 4. That's fine. And then 4 and 4 will both break down, right? So they both break down 2 and 2, and those are primes. Break down the other one, 2 and 2, and those are primes. Now, the reason I make sure I circle my primes is because I don't want to use my 2s and the 4s and the 16, because then I've reused a lot of stuff, right? I get all of these 2s from the 4s, and I got the 4s from the 16. So don't use everything, just the prime ones. That's why I circle them. All right, and then I'm looking for pairs. So I have a pair of 2s. Pair of 2s comes out as one couple, right? Just 1, 2 comes out. I have another pair of 2s. So they're going to come out as another 2. And then what do I do with leftovers? Inside. Leftovers in the fridge, right? He's going to go in there. And then can you clean this up? 2 times 2 is 4. So 4 times the square root of 2. And that is a simplified radical. If you have a calculator in front of you, which you should when you walk in here every day, if you would type in the square root of 32, type that in, see what decimal you get. Okay, and then type in 4 times the square root of 2 and see what decimal you get. It's the same thing. Yeah, so guys, you can always double check to make sure. If you type in square root of 32, look at what it is as a decimal, type in your answer. It should be the same thing. It's just simplified. That's all I've done. I've simplified it. All right, let's take a look at number 2. Square root of 54. Is 54 perfect? No. All right, so let's do a factor tree. What do you multiply to get 54? 2 and 27. I am loving you guys that you start with 2s, because I typically where I go with it, because I can do mental math a lot faster dividing by 2. And they usually yell at me. They're like, oh my God, this is going to take forever. I'm like, you end up with the same number of numbers at the end. But people don't like that. All right. I had a student once, I got to tell you this though, a couple years ago, he was really into the divide by 2, he loved that. But then if it got to 27, he was out. He didn't know what to do. Move on to a 3, right? He wouldn't. Everything was 2. He didn't know what to do if it wasn't 2. All right, so 27, 3 and 9. 3 is done, so we'll circle that one. And then 9, 3 and 3, and we'll circle those. Yeah. So then when I go to look for pairs, what do you have a pair of? A pair of 3s. So they come out as 1, 3, right? It's a couple now. Oh, I know. That's so sweet. They're on a date. Want to go see a movie? And then what do I do with the 2 and the 3? They're leftovers. Leftovers go in underneath the radical. They go in the fridge. What does it become when I put them in there? 6. Good. You just multiply them back together. How do I check that to make sure I did it right? Calculator. Yeah. You could type in square root of 54. Type in 3 times the square root of 6. They should be the same. Just like 1/2 is the same as 5/10. They look different, but they're both 0.5. They mean the same thing. All right, why don't you guys try 224 on your own? All right, walking around, they look pretty good. So what did you multiply, or what did you break down the 224 as? 2 and 112. That's where I would have went. And then 112, I would have went 2 and 56. That's mental math I can do pretty easy. And then 2 and 28. 2 and 14. 2 and 7. I'm obnoxious. I like the 2s. All right. Did anybody go a different route than I did? Did you end up with the same number circled as I did? The same. Look at the numbers I circled. If you did not break it down the same, do you still have the same numbers circled? You do. It doesn't matter if I would have broken it down. There's so many different ways I could have went. But in the end, you would have 1, 2, 3, 4, 5 2s and a 7. No matter which way you go, 5 2s and a 7 is where you end up. All right, so I'm looking for pairs. So there's a pair of 2s that comes out. I got another pair of 2s that comes out. And then where do I put the leftovers? Inside. What's it become? Good. A 2 and a 7 make 14. 2 times 2 is 4. Radical 14. So a couple things I noticed students have done in the past that are going to mess you up. One is they don't circle their prime numbers. And then they end up using numbers they shouldn't use. So make sure you circle them. And then if you notice what I do when I find pairs, what do I do with my circled numbers? I'm crossing them out. That way I know what I've used and what I haven't used. It seems obvious, but some students are that lazy. I mean, I'm all about being lazy. Trust me. I like laziness. But it's helpful. Okay? Number 4, there's a number out in front. What is that? That's the other couple you're double dating with. They're already at the restaurant. They're waiting for you to get there. Okay? They're already outside. So when I'm simplifying radical 48, do I need to worry about this when I make my factor tree? No. They're already at the restaurant. I am not with them yet. I have not left my house, right? I'm still in my house. I'm underneath. I need to come out of the house before I can meet with them. So we're going to break down the 48. So what, 2 and 24? 2 and 12? 2 and 6? 2 and 3? Love the 2s. All right. Do you have any pairs? Good. I have 2 sets of 2. So there's a pair of 2s. Another pair of 2s. Left over in the fridge. Now, what happened to that couple I was supposed to meet at the restaurant? Where are they? Do you see them up here? I can meet with them now. I came out of the house. I'm there. I'm at the restaurant. I can meet with that other couple. So that kind of just follows me down. I'm going to multiply them then. What's 3 times 2 times 2? That is 12. So I have 12 radical 3. Do you like my stupid analogies so far? I have lots of them. It don't matter. It doesn't matter. It really doesn't matter. All right. What about number 5? There's a negative number. I just have some really cynical friends at the restaurant, right? Or negative people. It doesn't matter. It's just a number. It doesn't matter that it's negative. I'm still going to attack the radical the same way. So how are you breaking down 108? He's one of those people. 9 and 12. Wasn't 2 and 54 like I would. That's fine. Doesn't matter. All right, because off the top of my head, will I know 9 times 12 is 108? I don't. If you do, that's awesome. I just don't know it. All right, that's fine. So then we can break down the 9, 3 and 3, which I'll circle those. What'd you do with 12? Of course you did. And the 4, 2 and 2. He's avoiding my 2s as far as he can. All right, I'm looking for pairs. What do we got a pair of? Good. Pair of 3s, pair of 2s, leftovers, in the fridge. And that couple that I was meeting there that's already at the restaurant, now I can bring them down, and I can put them all together. Negative 5 times 3 times 2, it's negative 30. And then a radical 3. They do. Everybody knows people like that, right? All right, number 6, on your own. All right, so here we go. How'd you break down 600? You know, it's amazing to me how many people don't think of 600 as 6 and 100. Like you literally say it, right? People are like, oh yeah, I didn't think about that. But does it matter that he went 6 and 100? Somebody else I know went 2 and 300. Does it matter? It doesn't matter. You end up same spot. All right, so 2 and 3. You went 10 and 10, didn't you? Oh, you did go 2. Okay. I was assuming you were avoiding that. 5 and 10? Not 2 and 25. Oh, you did? Okay. All right. You should end up same spot. All right. So once you break them all down, what do I have a pair of? Got a pair of 2s, pair of 5s. I have a leftover 3 and a leftover 2. So that becomes 6. See that guy? Those people right there? Already at the restaurant? Some of you just lost those. Walking around, you had a 10 in front, you just forgot the people you were meeting. You're rude. How dare you go to the restaurant when they're there waiting for you and you don't even, like, find them. So, negative 40, radical 6. All right, questions, comments, concerns with simplifying a basic radical?